Hey there, how's it going? It's Mr. Murray with a video on rational functions, expressions, and equations. And I'm both happy and sad to tell you that at this point, we've reached the end of our final major unit of Course 2 honors. And it feels like just yesterday that we were really, you know, wrapping our head around the fundamental ideas and really jumping into it head first. And now here we are at the end of the year, getting ready to put a close on things. So in this video, I'm going to be talking about the four main ideas that we discussed in our mini unit this year in 2019-2020. Okay, the first was graphing rational functions roughly. So we only talked about how to make kind of like a rough sketch using the vertical and horizontal asymptotes and two reference points. We found the reference points by making the denominator 1 and then -1 because those are easy numbers to divide by. We talked about analyzing rational functions, particularly with regard to the domain and range, because those are unique to those type of functions. And what I mean is that the idea that the domain is everything but one number and the range could be everything but one number, that's really unique. Usually we're used to the domain being either everything, right? That's what we're used, or sometimes with piecewise you get some funky things. And the range, we're used to seeing either everything or some kind of like maybe all positive numbers or like a whole range, but we're usually not used to seeing everything but just like one number plucked out. Okay, we then talked about performing arithmetic with rational expressions. So we spent some time talking about first how to multiply and divide, then we extended that to addition and subtraction, and finally we used our knowledge of working with expressions to solve equations involving rational expressions. Okay, so you can see here I've got an example of a rational graph, a rational equation, and a rational expression. Notice the equation has an equal sign, so I'm going to want to know what the variable is equal to, whereas the expression does not, and I'm going to simply ask you to simplify. Okay, and so through this video, I'm going to be talking about these topics. There's going to be one set of problems on graphing and analyzing, one on performing, and one on the performing arithmetic rather, and one on the solving. And so essentially, what I'm going to do is each one will have problems where I'll do one, and then there will be one for you to try as well. All right, so the first skill has to do with graphing and analyzing. So we talked about how a rational function is just simply a function that's created by taking the ratio of a polynomial to another polynomial. This is the general form of a rational function. You can see the h and the k are present here, and the h and the k we talked about in the video on graphing rational functions. It is directly connected to the horizontal and vertical asymptotes. Okay, so that's one thing that's probably important to know. Okay, so based on that, we're going to see what we can do about graphing. So remember, our strategy for graphing was we were going to work smarter, not harder. We first find the asymptotes, find the reference points, and we make a rough sketch from there. Next year, you guys will revisit, I've been told, this concept. So that's why the idea is just to get your feet wet, expose you to some ideas and how they line up and extend what we've already talked about. But if this is something that's still difficult for you, don't worry, it's okay. So first I'm going to find the vertical asymptote. Now, finding the vertical asymptote means finding the number which, if I was to plug it in, would give me a really big issue. And that is x is equal to -5. Because if I plug in -5, right, the function will be undefined because you cannot have 0 in a denominator, right? We know that. Okay, 1, 2, 3, 4, 5. So this is the vertical asymptote. The horizontal asymptote is always represented by the k value, and that represents a y value, an output that the function gets really close to, but never quite gets to. Okay, so let's do a line. I'm going to make this one purple so we can see both different types. So here's my vertical asymptote. And some of you might be saying, Mr. Murray, put arrows on the end. And if you want to be like that, then I respect it. Boom, boom. Okay. Now, just remember the reason that we have the horizontal asymptote, the reason it's just the k value. Remember that 1 over x minus 5 is going to either be essentially 0 if, let's say I plug in 100. That's going to give me a really small number, right? So as x gets really, really big, 1 over x plus 5 is getting really, 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 really small. So essentially, it's getting close to 0. So when x is big enough, all that's left is negative 2. Now, it's not the same as negative 2 because 1 over x plus 5 is not 0, right? But it's very, very close. All right, and that will be true no matter what k is. It's always going to be close to whatever that k value is. Now, I want reference points. So to get my reference points, I'm going to try my best to make this as easy as possible. So I'm going to plug in negative 4. You're just going to choose 2 and plug them in. And I'm going to plug in negative 4 because negative 4 plus 5 is 1. So I've got 4 times 1 minus 2, which is 2. So I've got 1, 2, 3, 4, 1, 2. And then I'm going to plug in negative 6, because when I plug in 6, I get 4 times negative 1 minus 2. Because it's negative 6 plus 5, and that's going to be negative 6. Because it's 4 times negative 1, which is negative 4, minus 6. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. Okay, and then I'm just going to make myself a rough graph. Okay, because remember, the point of the reference points is just to tell you essentially where the function's living. Now, next year, we got to think about the fact that there is a dilation, right? That a value is having some stretching impact. And to see what impact it exactly has, okay, again, keep in mind you'll be revisiting it again. But remember, we can just easily find the vertical and horizontal asymptotes, a couple quick reference points just by choosing a nice, easy numbers to plug in, relatively speaking, and then making us a rough graph from there. Okay, the domain here is x is everything but 5, or negative 5 rather. So x is not equal to 5, y is not equal to negative 2. You could also say, for example, negative infinity to negative 5, u negative 5 to infinity, right? There's 3 different ways of saying it, even more. So I'll leave that to your teacher next year with regard to what they want to do. This is fine for me right now. All right, so now I'm going to do this one, and this is one for you to try. So what I'd like you to do is please take a moment, pause the video, try to graph this rational function, and then when you're ready, unpause, and you can see what I got. So I'm going to start by finding my vertical and horizontal asymptotes. So vertical asymptote, what will make the bottom undefined? X is equal to negative 2.5, because negative 2.5 times 2 is negative 5. Negative 5 plus 5 is 0. So that will be undefined. Horizontal asymptote, y equals 3. Okay, so let's go ahead and graph that out. Okay, let's start with our vertical asymptote, negative 2.5. Okay, horizontal asymptote, 3. Just for consistency, I think if it's okay with you guys, I'll make this one dotted. Okay, we're going to be in technical. I'll add my arrows on the end. I wouldn't want to upset anyone. And remember, now I'm going to choose my 2 reference points. Okay, so make sure you've chosen your reference points. So I want to make this 1. 2x plus 5 is equal to 1. In other words, 2x plus 5 is negative 4. So if x equals negative 2, this is negative 4 plus 5 is 1. So it's negative 1 plus 3, which is 2. So negative 2, 2. Okay. Now, what if it's equal to negative 1? Then if x equal to negative 3 times 2 is negative 6, plus 5 is negative 1. So I have negative 1 plus 3, which is 1 plus 3, which is 4. So I've got 1, 2, 3, 1, 2, 3, 4. Okay, I'll try to get as close to it as I can. So you can see we got a little bit of a reflection there. Okay, and then for our domain, x is not equal to negative 2.5, and y is not equal to 3. Okay, folks, so the next thing we're going to do is we're going to talk about performing arithmetic, okay, with two or more rational expressions. And so when I say arithmetic, that means addition, subtraction, multiplication, or division. Now remember, we talked about multiplication and division first, and in retrospect, I actually do think that's a good idea because in general, multiplication and division with fractions is actually easier if you think about it, because you don't actually have to have the denominators equal. You can just straight up just carry out the operation, and then you just have to make sure it's simplified. But that's easier than trying to finagle your way into equivalent denominators. So when we're multiplying and dividing, the first thing we're going to do is we are going to try to factor everything. We want to do this because once we factor everything, we want to cancel, okay? Things should start to cancel out because you should see factors that are being repeating. If not, then you can't cancel, okay? Then you're going to multiply across the top, and you're going to multiply across the bottom, bottom to bottom. That's going to get you your new quotient, and then you will simplify as needed, okay? All right, now what if you're adding or subtracting? So that's going to start the same. I'm going to suggest that we probably want to start by factoring everything, okay? I want to factor everything really, because what we want to do is we want to find the least common denominator. Okay, we need to find the least common denominator, and then once we have the least common denominator, right, just like with fractions, we're going to use ones, okay, to make all denominators equal. All right, and then we either add or subtract the numerators, depending on if we're adding or subtracting, and then we simplify as needed. Okay? All right, so let's see what we got. So in these ones, we're going to start by multiplying and dividing, and then we're going to state the excluded values. Remember, the excluded values could be either from each of the pieces, or it could be from the final answer. So please make sure you keep that in mind. So the first thing I'm going to do is I'm going to factor. So I'm going to, right, you want to factor. So I'm going to take out that 10, and actually I'm going to do a 10x squared, and I've got a 5x plus 1. Okay, here I've got a 10 down bottom, 5x plus 1. So let's see what can cancel. This 10x squared and this 10x squared, this 5x plus 1 and this 5x plus 1, and then this 5 and this 10. So I end up with a half. And then the excluded values, x cannot be 0 because that will make this 0. X cannot be negative 1/5 because that will make this 0. All right, moving on over. Remember, we're gonna factor. So the GCF here that we'll have is going to be 6x. So it'll be 3x minus 2. and then this will cancel, and this will cancel. So we get 6x over x plus 8. Excluded values, x equals 2/3, because that would make this 0. X equal -8, because that would make this 0. All right, division, similar, but we have to do one other thing with excluded values. We just have to remember to do the excluded values of the right-hand part both before and after we do the change. So remember, whenever we see the multiplication, we're going to do keep, change, and then we're going to flip it. So 5x squared, 15x squared minus 24x. Okay, so we kept, changed, flipped. Now let's simplify. So this is going to be 3x. So we'll have 5x minus 8. Okay. Now this is the same as, actually, if I pull out a negative from that, I could make it 8 minus 5x. And then if I do that, this will cancel with this. So I have -3 over, or rather -3x over 5x squared. And then an x will cancel, so I have -3 over 5x. Okay, and lastly, same idea. Let's start by do like a little rewrite. 3n squared minus 27n minus 30 over 10n. Change, flip. Now real quick, I just noticed I didn't do my excluded values here. So here, so I would have 0. Remember to do your not equals is. So this would be a 0, because that would make this denominator 0. That would make this denominator 0 after the flip, and this one before the flip. All right, and the last one is x cannot be equal to 8/5, because if it is, then you will also have 0 denominator. Okay, anyway, over here, you do the flip. The 10n's are going to cancel, and let's factor. So up here, we're going to have a GCF. We'll pull out the 3. N squared plus 9n minus 10, which is equal to 3 times n minus 10 times n plus 1. And this is 24 times n plus 1. So the n plus 1's cancel. Isn't that interesting? And then the 3, that'll cancel and become a 1. And the 24 will become an 8. Okay, and so what I have is n minus 10 over 8. Excluded values, n cannot be equal to -1. It cannot be equal to 0. It cannot be equal to 10. Okay, because -1 makes this 0. 10 makes this 0. -1 makes this 0. And 0 makes that one 0. All right, time to add or subtract. So again, the idea here is we are going to add or subtract these. And remember, we're going to need to make the denominators equal to one another, as with any fraction, because with addition and subtraction, you cannot add unequal denominators. It's like trying to combine like terms when you're not actually having like terms, right? Like you can't combine x's and y's. You can't combine halves and thirds, because those are not the same thing. You've got halves and you've got thirds. So you need to turn them into the same thing. And then once they're all sixths, you can combine them. Okay? So what I'm going to do here is I'm going to get my LCD. And my LCD is going to be x plus 6 times 3x minus 4. In some cases, you just simply have to multiply each of them by each other. keeping in mind that you may need to simplify. Okay. Now remember, in this one, we do need to multiply top and bottom because we want to keep everything equivalent in value, but just looking different. So don't forget about that. That's extremely important. Okay, so I've got 9x minus 12 plus 6x squared plus 36x over x plus 6 times 3x minus 4. Okay, and then if I clean this up, I get 6x squared plus 45x, okay, minus 12. Okay, so make sure you got the same thing as me there. Excluded values. Now I could factor out a 3 if I want. I'm not gonna. Excluded values, -6 and 4/3. All right, this one's a little bit more straightforward. The LCD here is going to be 6a, right? Because if I multiply this by 3 over 3, I get 6b over 6a minus 3 over 6a. Denominators are equal. I subtract across the top. 6b minus 3 over 6a. Excluded values. A cannot be 0. All right, last but not least, let's start by factoring this. So there's a 6 as a GCF. So let's see. A squared plus 4a. A squared plus 4a plus 4, which is 6 times a plus 2 times a plus 2. Okay, so I'm going to need to multiply this by 3 a plus 2, a plus 2. So that's 2 plus 15a, a plus 2, a plus 2. Because remember, you want to multiply top and bottom by 3, a plus 2, a plus 2. Once you do this, right, this will become 6 of them, and they'll be the same. 6, a plus 2, a plus 2. Something to that effect. And then you get a cannot be equal to -2. I'll tell you on the test, likely you're going to have things a little bit cleaning up a little bit nicer than this. All right, folks, so your turn. Please go ahead, add, subtract, multiply, divide, whatever is appropriate. Okay, I'll go ahead and actually combine these into one window. So I have 1, 2, 3, 4, and I'm going to bring these up so you can see them all together. So I've got these 6. Okay, what I want you to do, please pause the video, simplify these 6, then when you're ready, unpause, and you can see what I got. Okay, guys, so let's start with the first one. Okay, in the first one, I need to multiply the top. I'm going to multiply across the top and the bottom, but first I need to simplify. So I'm going to take out my greatest common factor of 9r, and what I get is r plus 2, 9r squared, 18r. The r plus 2's cancel, and I get 9r over r minus 2. Excluded value, r is not equal to 2. If you forgot the excluded values, you may want to pause and go back to that. Okay, here we'll start with the flip. So 8k cubed minus 16k squared over k minus 5. Change 5k plus 2 over 40k cubed plus 16k squared. Okay, so let's start by factoring. 8k squared over k minus 2. Okay, this is 8k squared times 5k plus 2. Okay, so the 5k plus 2 and the 5k plus 2 are going to cancel. This 8k squared and this 8k squared are going to cancel. So all I'm left with is k minus 2 over k minus 5. Excluded values. K is not equal to 5. It's not equal to negative 2.5 because that will make this 0. And then when I flip it, there's that 0. So it can't be equal to 0 either. All right, here's another multiplication. So here, let's just start by factoring. This is x plus 10, x minus 9. This is x plus 10, x plus 4. This is x plus 4, x minus 4, and that's not factorable. So the 4, x plus 4, x plus 4, x plus 10, x plus 10. And then I can take out a negative and make this 9 minus x. So I've got negative x minus 4. Or rather, I guess, distribute, and I get negative x plus 4. And everything on the bottom is canceled. Excluded values. X cannot be equal to 9. X cannot be equal to 10. X cannot be equal to negative 4. And here is equal to positive 4. All right, here, let's start with a little bit of subtraction. So let's start by factoring. So we've got 4v times v plus 1. Okay? So first of all, my excluded values, v is not equal to negative 1, and v is not equal to 0. All right, so now I'm going to need to multiply this by 2v times v plus 1 over 2v times v plus 1, because I multiply and I get the 4v. So we've got 3 over 4v times v plus 1 minus 14v times v plus 1 over 4v v plus 1. So I've got negative 14v squared minus 14v plus 3 over 4v times v plus 1. Excluded values, v cannot be 0, v cannot be negative 1. All right, last couple, these are just ones. This one you're just going to have to multiply one by another. So x plus 7, x plus 7, x minus 8, x minus 8. So I've got 3x minus 24 plus 4x plus 28 over x plus 7, x plus 8. So that's 7x plus 4 over x plus 7, x plus 8. Excluded values, x is not equal to negative 7 or 8. All right, last one, let's factor this. So 5n squared plus 7n minus 8. So it's 5n minus n plus 8 n minus 1. Okay, that's interesting. So the issue is the greatest common factors There aren't really any. It makes this a lot more challenging. Okay, so what I'm going to do is the LCD is going to be 15n times n plus 8 times n minus 1. Okay, so when I do that, I get 15n squared plus 15n, okay, plus 7n, or rather plus 7n, and then we also have to multiply by this 5, so plus 35n times n plus 8 times n minus 1, all over 15n times n plus 8 n minus 1. Okay, excluded values, n is not 0, n is not negative 8, n is not 1. Okay, there is more simplifying you are going to do, but for here, I'm just going to give you kind of like a glance over quickly at it. All right, lastly, solving equations. So here, I broke this down in the last video on solving equations into just a few steps. Okay, so here you want to first find any excluded values, and you're finding those factoring ahead of time if needed, so you can feel free to do step 2 first if you need to factor to find the excluded values. Okay, but you need to first find those because those cannot be possible solutions. Then you're going to factor everything, especially denominators. You're going to find the LCD of all expressions and multiply by the LCD to clear every single denominator. Simplifying as you do so, you're going to get whatever variable you need to alone. Any excluded solutions will be thrown out, right? So if any single answer, because you could get more than one, is one of the excluded values, you throw it out as extraneous, and then you should plug back in just to make sure that it's actually a solution. All right, let's take a look at a couple of examples, and then as usual, I pass them off for you to try. Okay, so here, what we're going to do is we're first going to try to factor everything, and that's done. So the excluded value here, x is not 0. So I'll keep that in mind. And now I'm going to multiply. Well, what's my least common denominator? Okay, what it is it is 6x squared. So I'm going to multiply everything by 6x squared. This by 6x squared. This by 6x squared. Because you multiplied everything by the same thing, the equation remains balanced. So this will become a 3. It's become a 2. So I got 2 equals 3x plus 9 minus 1. 2 equals 3x plus 8. Negative 6 equals 3x. X equals negative 2. Is it an excluded value? It is not. Okay, so if we plug it in, let's see what I get. So negative 2, so that's 1/12. All right, plus 3 is 1. 1/8 minus 1/24. Okay, so that's 2/12. That's 3/24. So, sorry, 2/24, 3/24 minus 1/24. Yep, it checks out. All right. Second one. First, let's start by factoring because it's not clear what's going on here. So this is b minus 5, b minus 2. All right, obviously same thing here. They're equivalent. So remember, excluded values, b cannot be 5, 2, and actually that's it. Okay, LCD, it's going to be b minus 5 and b minus 2. That's the most simple thing that will cancel everything. So I multiply this by b minus 5, b minus 2. this by b minus 5, b minus 2, this by b minus 5, b minus 2. So here the whole thing cancels, and the 2 cancels. So we got 1 plus b minus 5 equals 2. So I've got b minus 4 equals 2. So b is equal to 6. It is not an excluded value, so we're good to go. All right, last one before I pass it off to you. This one's very similar. So this is going to be x minus 6, x minus 3. So I'm going to multiply everything by that. All right, x minus 6, x minus 3. That will cancel out these whole things. So I've got 5x minus 20 plus x minus 3 equals x minus 4. So I have 6x minus 23 equals x minus 4. So 5x equals 19. So x equals 19 fifths, which is not an excluded value, because the excluded values, which we should have probably listed, would have been 6 or 3. All right, last opportunity for you to try. Please take a moment, pause the video, solve these 4 rational equations. Then when you're ready, unpause, and you can see what I got. All right, so what I'm going to do is I'm actually going to probably highlight these and move these ones down so I can work on one thing at a time. All right, so this is k plus 2, k plus 3. This is also k plus 2, k plus 3. So excludeds, k cannot equal -3 or -2. So I'm going to multiply through by k plus 2, k plus 3, k plus 2, k plus 3, k plus 2, right? That balances it. In these cases, the whole denominator gets canceled, while in this case, only the k plus 3 gets canceled. So I've got 3 minus k plus 6 equals k plus 2. So I've got 9 equals 2k plus 2. So 2k equals 7. So k equals 7 halves, which is not an excluded value. So we're good to go. All right, moving on down. K squared plus k. Well, that's k times k plus 1. So it looks like our excluded values are 2. K is not 0, and k is not -1. So my GCF, I'm going to multiply through by k times k plus 1. Okay, remember, if your denominators don't all cancel, you got to rethink things here. So here, these cancel. Here, the k, and that is what it is. So all denominators should be gone. And see, in this case, they are. Plus 5k squared plus 5k all right, so k plus 1 equals 5k squared plus 5k plus 1. So 5k squared plus 4k equals 0. So 0 equals 5k, actually just k, 5k plus 4. So either k is equal to 0 or k is equal to negative 4/5. But k can't be 0. So basically what that means is that k is negative 4/5. All right, we're really making some good progress here. Moving on down to that next one. And I've got this one here. Okay, so excluded values, r equals 2, r equals negative 3. I'm going to multiply through by r minus 2, r plus 3, r minus 2, r plus 3, r minus 2, r plus 3. So we've got r minus 2 plus r squared plus 2r minus 8. Oh, we're supposed to be doing plus 3 though. So r squared plus 7r plus 12 plus 6r plus 18. And the equal sign needs to go after the r plus 2. R minus 2 rather. So r minus 2 equals r squared plus 13r plus 30. We're not ready to factor just yet. 0 equals r squared plus 12r plus 32. Some of you might be tempted to factor, but you can't factor to the left until you have it equal to 0. Okay, so 0 equals r plus 8, r plus 4. So r equals negative 8 or negative 4, which are allowed because they're not considered excluded values. All right, here we are. Last but least, let's start by factoring this one out. So this is n minus 4, n plus 1, and that is the LCD. So first of all, excluded values, no 4 or negative 1. So let's multiply everything through by this. Okay, multiply everything through by this. Okay, so here, these are going to cancel entirely. Here, so we'll get 2 plus n squared minus 3n minus 4 equals, here the n plus 1's cancel out, n squared minus 16. So here the n squareds are going to cancel. I'm going to get, let's see, negative 3n minus 2 is negative 16. So negative 3n equals negative 18. So n equals 9, which is, n equals 6, which is not excluded. All right, folks, hopefully you're able to get all these correct. Again, today's focus is going to be on review. And hopefully you found this video to be helpful as well. Best of luck today. Don't forget to love math. And remember, you can do it.